Okay, good morning students. Today we are going to perform the internal and external characteristics of DC shunt generator. First of all, this is what the circuit diagram is. As per the circuit diagram, first of all we have to use our prime mover. As a prime mover we are using a DC shunt motor, and for that we require a DC supply. Here to generate a DC supply, what we have done, this is our three-phase AC supply. The three-phase AC supply has been fed to this three-phase variac. The three-phase variac will change the AC three-phase AC voltage, and this variable AC voltage at this output terminus has been fed to this rectifier circuit. The rectifier circuit here R, Y, B, three-phase AC voltage will come, and from here plus and minus we will get our DC supply, variable DC supply. So from this plus and minus our DC supply has been started, which has been fed to this DC shunt motor. Now let's verify the circuit diagram. As far as the circuit diagram is concerned, from positive of the supply, the means it is going to enter into the rheostat, and as well as it will enter into the armature winding of the motor. From the rheostat it will enter into the field winding, and output of the armature winding and the field winding, means double and double Z, are going to be short circuited and coming back to that supply system negative. Now let's verify whether it is connected according to this or not. So here from this positive, as it is visible, it is entering into the motor armature winding, as well as it is also entering into the rheostat. The output of the rheostat, it is entering into the field winding Z, and finally the output of the armature winding AA and output of the field winding double Z, both are getting short circuited and coming back to that supply system negative. So this is the motor connections are finished. Here this particular voltmeter has been connected across the supply voltage. This voltmeter will measure the supply voltage of the motor. Now as far as the generator circuit diagrams are connected, generator circuit diagram is concerned, this is our generator armature winding from which the current will start. It is going to enter into the rheostat. From rheostat it will enter into the field winding, and from field winding it is going to enter into the ammeter. This particular ammeter will measure our field current. Armature winding is also going to fed to this ammeter. Through this ammeter it is going to enter into the load. So this particular ammeter will measure the load current. And here we have connected one voltmeter across the load, which is going to measure the terminal voltage of the generator. Now let's verify the circuit diagram. As far as the circuit diagram is concerned, so from this armature winding A, generator armature winding A, first of all it is entering through this blue wire, it is entering to this field winding. Output of the field winding is entered in this particular rheostat. Here we have connected two rheostats in series to increase the resistance. So from this rheostat, this second rheostat is connected in series. From this rheostat, second rheostat output, it is entering into this particular ammeter. So this ammeter is going to measure your field current, and output of field current, output of this ammeter is coming back to that supply system negative, this AA, armature winding, second winding, this AA. So this is the field winding. Now second terminal from armature winding A, it is going to fed to this particular ammeter, and through this ammeter it is going to fed this load. So ultimately this ammeter is going to measure our load current. Now here to increase the capacity of our load, we have connected two lamp loads in parallel so that we can increase our load capacity. Ultimately this voltmeter connected across this load, which is going to measure our terminal voltage. So this was the circuit diagram explanation. Now we will see how it is going to work.